up to section 1.8. Apologies to those of you who've been waiting for some of the videos. I hear I need to get working and get them out a bit faster, so I'll endeavour to do that over the next few days. Perpendicular and parallel lines, really easy stuff, all revision. Perpendicular means at right angles, so perpendicular lines are at right angles to each other. Parallel lines travelling in the same direction. So what does that mean? Parallel lines are going to have the same gradient. So the easiest way to tell if lines are parallel, get them into the gradient and intercept form. You can see these two lines here, y equals 3x take 1 and 3x plus 8. They've got the same gradient of 3, so they would be parallel. If we want to have a look at what they would look like, we can go and have a look at Desmos, just to give us a bit of a refresher. Now y equals, try and get it back in the screen here. That's a better looking size. Y equals 3x take 1. Y equals 3x plus 8. Now you can do that on your graphics calculator or anything. You can see straight away the only thing that's changed is the intercept. Everything else is, the gradient is the same, so the rate of increase is the same. So those two lines are parallel, they're not going to meet. Let's go back and see what else we've got. Perpendicular lines have gradients that multiply to equal -1. Or the other way of thinking about it is the gradient of one is the negative reciprocal, turn the fraction upside down, of the other one. So let's go back and look at our Desmos again. This first equation had a gradient of 3. The negative reciprocal of 3 would be -1/3. If we make that -1/3, you can see there those two lines are now at right angles to each other. So pretty straightforward. If they multiply to equal -1, 3 by -1/3, that'd be -1. Or if one gradient is the negative reciprocal of the other, you know that those lines will be perpendicular. How could I actually find an equation of a line parallel to another one? Well, you let the gradient be the same as whatever the line you were given is, and then just substitute in a point. The worked examples from the textbook are pretty easy for this one. I don't think you're going to find them too difficult or challenging, so you can have a look at those if you want to. Otherwise, I'd be getting straight into that diagnostic stuff from Hot Maths and straight into the exercise. It's only a little short one, and you shouldn't have too many troubles. Alright, good luck. Cheers.